It was smaller than the world outside it and louder. Heat rolled through the building like a second weather, radiant, unrelenting. Sparks fell from a busy bench in lines like brief lightning. The air smelled of oil and hot metal, of sweat baked into cotton. Overhead, a single filament bulb swung, painting faces in brief crescents of light. Against a wall that had once held neat racks, hooks stood empty. A sign that had once misted tool inventory was blank where the numbers used to be. The toolboxes that remained were dented, their drawers jammed. The workers had learned to live with missing wrenches and with jigs rebuilt from parts cannibalized off older machines. They made do. They had to. Inside this factory, the task at hand was simple in sentence and impossible in practice. Produce P-47 Thunderbolts, and produce them fast enough to meet a sky full of need. The planes were not merely machines. They were lungs and armor for pilots, the fast answer to a theater of war that changed every week. But speed required metal, and metal required tools, and tools were the one thing the factory seemed to be running out of. They called this the machine shop, but it was also a hospital and a dormitory and a kitchen and an idea laboratory. Men and women slept on office couches. A foreman's cot stood next to the blueprint table. Shift changes were measured in coffee cups and the click of keys that were previously part of a lathe. Outside the gate, trains waited with bundled fuselages and crates of parts. Inside, the rhythm of hammers and presses decided whether those trains would ever leave full. It began with a cracked casting. A jagged seam split across a control horn as if lightning had been caught in the alloy. The cast aluminum, meant to be both feather-light and nearly unbreakable, failed under stress at a test bench. The first failure was so loud, the shop manager, who had been on his feet for 36 hours, felt the wooden floor vibrate beneath his boots. They wrapped the piece in a blanket and carried it to the back room, where the metallurgist worked with a magnifying glass, a fillet gauge, and an attention that moved like prayer. When they discovered hairline porosity, tiny voids inside the casting where air had been trapped, someone in the room said it aloud like a curse. It meant the mold had been fed too quickly. It meant the furnace was running hot in the wrong phase. It meant that somewhere between a shortage of skilled molders and an exhausted supply of proper molds, someone had been improvising. It also meant the part would have to be recast or scrapped. Either option would cost time they did not have. They tried to fix it the first night by the light of a single car headlamp, fashioning a makeshift press out of a jack and two oversized bolts. When the makeshift press failed with a hydraulic leak that sprayed oil over a handwritten schedule, the shop went quiet in the way a crowd does before a storm. Men who had been joking a minute before began to count the failures like beads on a string. Each broken casting was not only an engineering problem, it was a tally of someone's fatigue and someone else's family, a small, accumulating debt against the promise they had made outside the gate to deliver craft that would fly and return. The factory had been built for volume, but not for scarcity. Tool cribs were designed to feed line workers, not to be plundered for spare parts. Now, when a special fixture or a particular reamer was needed, there was a half-formed panic, then a slower, more practical creativity. An undersized bushing became the core of a jig when wrapped in braze and filed to fit. A lathe bed scavenged from a broken machine was realigned with shims and prayer. Sheet steel became a makeshift template. This was not the romance of invention. It was a kind of salvage, brave, stubborn, and precise. The challenge around the P-47 was not merely fabrication, but fidelity. The Thunderbolt was a heavy fighter, stout, fast, and designed to take punishment. Its wiring harnesses, control surfaces, landing gear struts, and engine mounts had to be not only accurate to fractions of an inch, but reliable under the violent conditions of combat. In the early months of the emergency, the factory had been asked to expand output by a factor its planners called significant. Men on the ground treated the word as a polite euphemism for a demand that would redraw their days. The R-2800 double wasp, the radial engine that powered many Thunderbolts, was a known quantity on drawings and in the minds of the machinists. The engine itself sat at the center of a constellation of parts: cowling flanges that must fit within tolerances, a supercharger linkage that could not bind at altitude, control pulleys that could not stretch. Each of those parts required tools the shop no longer had in surplus. For example, a specific reamer that would ensure the smooth bore of a control tube had been issued to another shop that week and not returned. That missing reamer would delay the line. When the chief foreman, an older man who moved like someone used to having time, surveyed the empty tool racks, he did not flinch. He had seen scarcity before. But even he sighed at the list of things they needed: fixtures that could handle light alloys without warping, proper heat treating cycles, calibrated gauges. They had lost access to some of the machine shops that normally specialized in fine finishing. Those shops had been redirected to armament work. The P-47 line became a corridor of improvisation, a place where the rule book was rewritten daily. At the center of the workshop's daily improvisation was a machinist named Tom. His real name is lost to the archive of faces, so here he is a composite voice pulled from many testimonies and observations. Tom was 23, with grease forever under his nails, and a brother in a fighter squadron overseas. He learned to read metal like a man reads a letter from home, slow, careful, searching for meaning in the grain. When he saw a casting fail, he saw not only wasted material, but a delayed chance that his brother might come home. "We fix stuff with whatever got handed to us," Tom said once in a low voice, speaking to a recorder years later. "If you could hammer it straight or cool it slower, you tried. If that didn't work, you made something else, took from a press, a gear, a dead engine." His words were spare. They matched the pragmatic economy of someone who had lived between midnight shifts and the whisper of freight trains. It was not all boys in overalls. Women filled half the benches and many of the jigs, threading rivets, checking tolerances, and moving fuselage sections with a muscle memory that came from both factory training and wartime necessity. One assembler, only 20, would make the same rivet run over and over until the pattern in her hands became a language. Another, who had once been a school teacher, read cross-sections and torque specifications as if they were grammar. Their presence shifted the shop's cadence. Where men came with hands that were almost theatrical in their force, these women brought a relentless steadiness, sustained, precise, and profoundly ordinary. The foreman, a man known informally as Mac, kept a list of micro-solutions taped to his office wall. He wrote down things they tried and whether they succeeded. Cooling bath, works for small castings. Lathe shim, okay for short runs. Fan impeller rod, unstable at high RPMs. He encouraged experiments, but also recorded mistakes to be avoided. The factory was behaving like an organism under duress, seeking configuration points that allowed survival. If the machine shop was improvising at the bench level, the engineering office improvised with drawings. Harold, again a composite, spent nights bent over drafting paper, sketching a new bracket that eliminated one costly part and integrated two others into a single stamped piece. The drawing was bold in its simplicity. Remove a fastener, replace two parts with a stronger one, reduce assembly time by minutes that added up to hours by the end of a week. Harold's sketches were circulated with a stamp. Field tested? Not yet. They were taken to the floor, where Tom and the assemblers would try them, and when they cracked or warped, Harold would be recalled to the board to alter angles and radii. The test bench became the crucible of this emergency. Each new part would be run, sometimes at the test cell that simulated the hydraulic pressures of landing gear or the torsional forces of a dive. The tests were not gentle. In one brutal and unforgettable sequence, a batch of newly forged elevator control arms began to chatter under stress testing. The chatter grew into vibration, which, in turn, fretted a nearby bracket until the bracket failed. Fragments of test fixture flew across the room like thrown silver. No one laughed. The air got a little colder from the released pressure of nerves. Failures taught more than manuals ever could. After an early string of cracked valves and warped control levers, the metallurgist, and called simply the chief, insisted on a slow and simple experiment. They would heat a small sample to a specific temperature, hold it, measure grain size under the microscope, then cool it with one of 3 available quenching media: oil, water, and an improvised salt solution from a chemistry class's leftover reagents. The results were instructive. One medium produced a more stable microstructure that reduced brittleness. Another reduced tensile strength but improved shock resistance. The choice between them was a moral one and a technical one. Do you favor flexibility over sheer strength when you don't know which stress the part will meet in combat? The team did not always achieve consensus. Arguments could be ugly. Men threw terms like overkill and underspecified like barbs. But there was a kind of respect for materials that underpinned the quarrels. The metal spoke in ways that language could not. A failed casting told the story of an incorrect pour rate or an oxidized alloy. Each night, the workshop's whiteboard filled with corrections. Adjust pour temp minus 10 degrees F. Rotate sprue. Use bronze backing for weld. Sometimes annotated with small crushing notes like, no spare bronze, check yard. Scarcity had a moral geometry. When bronze was saved for critical welds, something else had to go. A decorative trim, a spare bracket, a training jig. The choices were made by people who often read rationing as both arithmetic and judgment. Some decisions were simply practical. Use hardened steel where soft steel would wear through in hours. Others were choices about risk and outcomes, about whether a pilot's chance of returning home could justify welding in a component not tested across full cycles. Then there were the nights when machines did extraordinary things. On a run of late-night production, the team decided to retool an existing stamping press to produce a reinforcement channel with a slightly altered cross-section. The press, older than anyone's last war story, shook fiercely during its first 3 attempts. Each try produced parts with a small lip that would catch paint and corrode. Each failure produced a growing pile of scrap. Someone suggested heating the die, improvising a localized thermal bath with blowtorches and asbestos pads. The idea was borderline audacious and arguably dangerous. They did it anyway, taking turns holding the torch to the die until the steel glowed just blue at the edges. The stamped channel slipped free like a cat when finally pressed, clean and true. For the first time that night, a group of machinists laughed out loud. A sudden sound of release that echoed off concrete like a released valve. Not every improvised solution was elegant. Some were grim necessities. When a critical sleeve bearing was missing and no supplier could deliver in time, the machinists machined a substitute from a scrap of oil can steel, then nicked it with a file to improve lubricant retention. It worked for 100 hours of test cycles. The men recorded its performance, marked it as provisional, and then offered the part to the line, where it became a small, stubborn victory. The plane that carried that substitute sleeve ran a mission and returned. There was, in these improvisations, a moral caution. The pieces that were made in such ways were stamped in the logbooks with notes. Field use only. Expedite replacement when available. They were acknowledgments that necessity had made a bridge across best practice, and that one day ideally soon, the bridge would be repaired with sanctioned parts. Outside the gate, logistics moved like a creature with 1,000 legs. Rail schedules were carved into the foreman's calendar, and the factory's ability to deliver hinged on wagons arriving with rivets, on crates of Aviono alloy arriving intact. Once, a sudden snowstorm stranded a shipment of precision drills. The shop responded by converting a jittery hand-powered drill into a near-rigid spindle using collars and a reworked chuck, and the line limped on. Another time, a supplier of hardened springs suffered damage in a bombing raid across the Atlantic. The foreman had to ration springs to landing gear assemblies and scrape non-critical kits for spare coils. Those logistical failures made the factory's human interdependence painfully visible. An assembler's work did not stop at the bench. She would walk across the floor to the storeroom, speak to the clerk, rewrite requisitions, and then walk to the adjoining shop to barter for a necessary piece. It became a network of favors, credits, and quiet debts. If a guy named Joe could spare a collar from a repaired lathe, he would be remembered. If a woman named Edna stayed an extra shift to rivet a fuselage, someone would bring her coffee the next morning. These small economies sustained the larger one. Amid the daily improvisations and the rationed tools, a higher sense of urgency pushed the team. Word filtered in from the airfields. Pilots reported that the P-47's sturdy airframe and armor made it a favorite on certain runs, and command wanted more. The factory's brass translated that demand into a push that was sometimes blunt and sometimes cruel. Deadlines were moved forward. Inspections increased in frequency. Paperwork that once might wait sat on the desk with red margins. But deadlines are abstract until a plane's tail section fails a vibration test, and someone pulls a small envelope from his pocket. A letter from a mother whose son flew a Thunderbolt and was missing in action. The letter sits on the same bench as the failure report. The men read it with hands that have been holding wrenches all day. It turns deadlines into stories. A drilling error cost a week. A week is a set of flights. A set of flights is someone's final chance. At the edge of the shop, in a dim corner near the painting booth that smelled of turpentine and sun, there was a bulletin board where the factory posted telegrams of congratulations and of sorrow. The board collected photos of returned pilots and those missing in action, of letters from families, and sometimes a simple photograph of a plane rolling off the line. The images were not meant to inspire, they were to remind. The team's small victories began to accumulate in ways that mattered. Little changes in the heat treatment schedule reduced brittleness in small fittings. A modified jig allowed a subassembly to be installed by 2 people instead of 4. A reworked routing of cable led to fewer interference problems in flight tests. Each improvement shaved minutes and inches off assembly time. And minute by minute, inch by inch, a factory that had once stared down scarcity found ways to bend circumstances in its favor. Not all improvements were technical. Morale adjustments were critical. Mac instituted a system where teams could petition for small luxuries, a chance to bring home a loaf of bread, an extra hour for a day off, if they hit weekly assembly quotas. On Fridays, when output was high, the loudspeakers in the shop played a few minutes of popular music while workers refilled water buckets and exchanged stories. It was not an affectation. It was a calculated humanistic engineering of productivity. When people felt seen, they tolerated scarcity longer. Yet the strain was always present. A woman named Ruth worked rivet runs at a station near the rear of the line. In her pocket, she carried a photograph of her son, who had shipped as a loader on a bomber and had not yet returned from duty. She tightened rivets with the kind of steady hand that suggested not fearlessness, but a profound practice of containment. She would sometimes stop at the stencil table to clean her hands, and her face would tighten for a moment, the strain of holding hope and a rivet gun at once. Her presence, like that of so many others, made the machine shop a place where private fears and public tasks were braided. By the time the team reached a point where the line could be considered stable, they had a list of things that, if solved, would allow full-rate production. A reliable supply of hardened reamers, a return of a specialist shop to perform fine finishing, an extra press to replace the one with a cracked frame. These were not glamorous items. They were wrenches and fixtures and scarce metals that, by any account, should have seemed mundane. But they were the keys to the factory's ability to meet the sky's demand. And then came the day of the endurance test that would determine whether their incremental work could hold under extended strain, a trial that would separate hopeful improvisation from reliable production. Preparations began in a hush. The test bench where the engine and control surfaces would run had been fortified with salvaged plates and clamps borrowed from the structural shop. A small team of machinists and engineers circled the assembly like a congregation around an altar. The metal glinted in the cold light. Tom adjusted a sensor with quick fingers, and Harold examined the blueprint one last time, lips moving as if reciting a prayer of angles. Outside, the factory's rail office had already confirmed a pending move. Should the test hold, a batch of fuselages would be winged and prepared for transport. Inside, the men and women had the practiced silence of those about to witness something consequential. It was not theatrics. It was the concentrated calm before a machine is asked to do the impossible again and again. A drum of oil was placed nearby. A heat lamp was adjusted to maintain a specific temperature for a control surface. The factory had learned that thermal conditions were as vital as mechanical fit. The microphone for the acoustic sensors was wired and tested. They had rehearsed procedures for failures: a cutoff switch, a cascade of alarms, a manual jack. Nobody wanted an explosion. They had seen enough of those. When the test began, the sound was not immediate thunder, but a slow building, a hum that edged toward a shout. RPMs crept upwards. The team watched gauges as if watching a child grow. Early readings showed low but stable vibration. A bead of sweat traced the foreman's temple. They logged numbers, exchanged nods. The plane's control surfaces oscillated under simulated turbulence. A sensor flagged a high-frequency spike and then dropped away like a ghost. For the first hour, nothing dramatic happened. Then a sound. The kind of sound that makes a man stop halfway through a sentence came from one of the hydraulic lines. It was a high-pitched whistle, the kind that announces a small, imminent failure. Tom moved without being told, hands working with the quick competence of someone who could read the language of machines. He tightened a clamp, a mechanic fed a spare hose, a woman soldered a connection. The seconds felt like minutes. The test continued. The whistle abated. They celebrated carefully at 70 minutes, and then again at 120. The machines held. The components that had cracked in earlier runs vibrated but did not break. Energy that once had been dissipated into fracture now flowed through designed pathways. The test was not over. It had to be sustained for the equivalent of several missions, for the kind of flight hours that translated into a genuine margin of safety for pilots. But this hour mattered in a way that paperwork did not. And yet, there were voices that punctured celebration with cautionary reality. A procurement clerk reminded the floor, "We still need proper reamers." A logistics officer warned that a rail strike could still delay shipments. The chief noted, with an almost scholarly patience, that the heat treatment used on test parts was a pilot and had yet to be validated across scale. Triumph and contingency walked together, a sober duet. If this scene pulls you in and you want more stories from the machinery and the hands that built them, consider liking the video. There's more inside these workshops than you might expect. The factory did not yet exhale. Even as the test stabilized, messages came in. A nearby depot requested an immediate retrofit for a batch in the field. A squadron wrote that replacement parts were in desperate need. The rail office called to say they had clearance for only half the wagons that week. It was a familiar cascade. One solved problem begets two new demands. Plans were set in motion to replicate the test's conditions across multiple benches. Harold and the chief sketched a folding plan to standardize the improved heat treatment schedule, to produce a set of jigs that could be replicated without the need for a specialized press that the shop lacked. Mac scheduled overtime in precise tiers, 3 shifts, 2 men on each critical station, to distribute fatigue and preserve knowledge. Yet for all the technical gains and careful scheduling, there remained a private ledger of loss. A telegram pinned to the bulletin board had arrived that morning. A pilot from a neighboring base was missing. The line worker who had known him, he had once come to the factory for a speaking engagement, stayed by the bulletin board long after his shift, tracing the edges of the photograph with a finger. It was a small, private grief that the factory absorbed into its larger story. As midnight approached, the test ran on. A rain of sparks from a nearby bench, where a separate team was fabricating a replacement bracket, lit the room in brief flares. The noise was intense but contained. The measured clatter of rivets, the low rumble of presses, the intermittent hiss of a grinding wheel. The factory, for all its improvisation and threat of scarcity, was still, in this moment, a place where human persistence met engineered chance. The run would not decide everything. No single test could. But it would test whether the small, accumulated corrections had become a system. If the bench held for the hours they planned, the team could argue for scaled adoption of their heat treatment, for the stamping die change, for the routing that allowed cable runs to be safer. It would give those in the procurement office the evidence they needed to plead for a return of hardened tooling. It would, perhaps most importantly, provide the shop with a story of arm's-length triumph, not heroic in a cinematic sense, but true. At 2 in the morning, the air felt thinner. The watchman by the doorway dozed with his head on a crate. Harold checked a dial and made a shorthand note. Tom tightened a bolt on instinct and adjusted a sensor. Outside, the rail yard clock ticked over to the hour that would decide whether a crate would be full or empty. The factory held its breath, in the way that a community holds a vigil, silently, with hope set against a ledger of fragile accomplishments. A small light on the instrumentation board flashed, a positive sign. It was almost imperceptible, like the first color in an overcast dawn. The run continued. The team watched, and in that watching, they remembered what had led them here. A series of small, stubborn acts of making do. The repurposed lathe bed, the coat of blue paint on a newly capsized jig, the quiet willingness of people to give up sleep. They had no guarantee the run would stay true for the duration. They did not have enough tools, but they had enough will to keep trying. And in the machine's steady hum, for a few moments, the shop felt like a place where what mattered most, the meeting of mind and matter, could still be made to hold. The test bench kept an even pitch. The vibration damped. The gauges whispered green. The factory leaned forward, not in triumph, but in measured, attentive relief, ready, as it always was, for the next thing that would break. They held the bench until dawn, because holding it felt like buying time, for parts, for the rail, for the men and women in the sky. When the morning shift came in, the test log was already smudged with coffee and grease, a green stamp across the top. Sustained. Harold folded the sheet and put it into a battered binder next to sketches and hand-scrawled notes. It would travel to procurement and, if the right people read it as more than a lucky night, to the blueprints office where a small army of detailers could begin to translate the shop's makeshift fixes into reproducible parts. Translation was the dull work of civilization, redrawing holes a few thousandths, specifying finish, ordering a coat of protective primer that would not flake under salt spray. It was the difference between a single successful bench and an assembly line that could be trusted flight after flight. The foreman sent a runner to the procurement office with the binder and instructions. Get us reamers. Get hardened drills. Get the press die heat-treated correctly. Get the specialist shop back. The runner ducked into the rain and vanished toward the depot, with the steps of someone carrying a message that could change a factory's life. Across the floor, the crew who had watched the run traded looks like people who had passed a test of more than metallurgy. Tom leaned against a column, his face tired, but edged with something like relief. He did what machinists do in quiet triumph. He cleaned a chuck, set a tool in place, practiced his motions. Ruth, who had kept rivets true for weeks at a time, wiped her hands slowly and then walked to the bulletin board to stare at the photograph of a pilot who'd come home. For a moment, the shop was ordinary. They ate, they fixed, they laughed at a joke half told. Then they walked back to the line because the sky would not wait. Scaling those bench successes into shoestring mass production required paperwork and politics and freight. The plant's engineering crew drew up a dozen minor changes that, collectively, might shave hours off each fuselage build. A simpler bracket, a stamped plate in place of 3 forgings, a rerouted cable that eliminated an awkward tie-down. These were the sorts of small economies that, when multiplied across hundreds of airframes, added up to aircraft ready for combat more quickly. The plan was to adopt the heat treatment schedule proven on the test bench, to standardize the die heating trick so operators could reproduce it safely, to machine a batch of the provisional sleeve bearings to a controlled tolerance while awaiting factory-made replacements. Plans met obstacles. Procurement could not conjure hardened reamers from thin air. They could request them, plead, and sometimes purchase them at the cost of another program's quota. Rail schedules had teeth. A single-stranded flat car could clog weeks. Overseas shipments were vulnerable to weather and enemy action. The factory's margins for error remained small. Still, human systems adjusted faster than paperwork could. A nearby locomotive shop offered a set of reamers for temporary loan. A metal finisher from a different plant volunteered to run a heat treatment cycle on nights when their workload eased. These were the soft economies of wartime: favors, credit notes, and mutual indebtedness that kept production moving. New hands joined the line. Men and women from other industries arrived and learned the Thunderbolt the way sailors learn a ship, by touch and repetition. On the bench, a young recruit named Luis learned to read the acceptable feel of a rivet as quickly as someone might read a face. He would place his hand over the rivet gun, feel the recoil, and know whether the part set with even pressure. There was an apprenticeship that could not be taught by blueprints. The way a fastener should sound when seated. The way a stamped flange should return to center after a press. Those instincts accumulated into a quiet competence that auditors could not quantify, but that mattered more perhaps than a dozen inspection stamps. Women continued to form the backbone of assembly. In the wing shop, Inez directed 2 crews at once, standing on a small box so that she might see the seam where riveting met skin. Her voice cut across the din with the authority of someone who had built order from chaos. She had been a seamstress before the war, and her fingers seemed to remember a different kind of stitching. "You don't rush a seam," she would tell recruits. "You listen to it." Her patience translated into fewer reworks and fewer late-night pulls from subassemblies that had, until then, been a factory's most stubborn enemies. Not every recruit adapted easily. Some parts required a discipline that was temperamental. The forging of landing gear trunnions, the careful finishing of bushings, the balancing of rotating assemblies. An operator who had never seen a high-speed spindle misjudged a feed once and burned a batch of splines so thoroughly the pieces had to be scrapped. Those scrapped parts arrived at the scrap pile like small memorials to inattention. They were also the most instructive items on the shop floor. Men and women would gather, examine the failures, point out the subtle telltale marks of improper coolant flow or wrong cutting speeds, and carry those lessons forward. Outside, the Thunderbolts were beginning to fly in inviting numbers. Pilots reported back about stubby stability, the comfort of heavy armor, and, crucially, that the aircraft's ruggedness often let them come back from hits that would have downed lesser fighters. These reports did not mean wholesale strategic change. Aircraft were instruments within larger operational frameworks. They could not, by themselves, win air campaigns. But repeated accounts of improved survivability meant the factory's work had real human consequences. Fewer funeral cards pinned to the bulletin board, a pilot's mother writing that her son had returned, scratched and tired, to tell her he owed the plane his life. With increased flight service came a different kind of scrutiny. Field reports highlighted new failure modes that only long-term operational use revealed. A control cable routing that seemed fine on the rig would, under months of vibration, chafe against a rivet and begin fraying. A stopgap bearing that survived a bench test faltered under the stress of repeated shock loads over many missions. Each new failure meant fresh rework, sometimes in theater, and for the factory, a renewed urgency to replace provisional fixes with hardened, certified parts. The logbooks filled with notes like replace bronze bushing with part number when available, inspect cable run at 100-hour intervals, and always the provisional mark, field use only. Defense of the home front meant the factory itself was a target in a different sense. Bombings across the ocean strained supply lines. Domestic security measures limited worker movement. Blackout curtains had to be drawn at dusk in many towns. The factory became a focal point of community anxiety and pride. On paydays, families lined up at the gates not just to collect wages, but to glimpse into the building where their sons and daughters spent long hours. Workers who returned home smelled of oil and paint and sounded like other people's sons. The community's reciprocity codified itself in small rituals. A neighbor would watch a child while a pair of shift workers finished a run. A church group would deliver pies to teams working overnight. The moral geometry of the place never quite settled. On one wall, a portrait of an Air Corps commander might hang next to a list of safety procedures. The men and women who produced the airframes understood their work's military purpose, but they were not sprinting in a vacuum of ideology. They knew that every plane delivered could be used in missions that killed, and they understood the human cost on both sides of a conflict. At the same time, there was an abiding conviction, sometimes perhaps a survival mechanism, that producing reliably built machines could mean more pilots returned alive. The tension between these beliefs was not reconciled. It simply existed as the air in the shop, sometimes light, sometimes thick. There were nights when the weight of that ambivalence pressed on people in tangible ways. After a run where 3 planes had come back damaged but repairable, a small group gathered around a folding table with a thermos of coffee and a weathered map of operational zones. A mechanic who'd once been a teacher traced a finger along a route and asked where the civilian cities lay in relation to the objectives. Conversation paused. Someone else changed the subject to a movie that would soon be showing at the local theater. These lapses into ordinary life were not denial, but a thin architecture of coping. As the months passed, the factory's improvisations were codified into documentation. Sketches were formalized into drawings. Temporary jigs were reproduced in shop metal with accurate tolerances. The plant began to talk in the language of standardization. Part numbers, revision letters, approved work instructions. That bureaucratic scaffolding felt at times like a bureaucratization of their small creative acts. But it was also liberation. Standardized parts could be ordered in bulk. Certified reamers could be procured. The provisional marks could be peeled off logs and replaced with proper part numbers. A second endurance run, carried out after the new procedures had been instituted, lasted 3 times longer than the first night's test. In the control room, monitors showed steadier harmonics. The chief metallurgist annotated a graph with a steady hand. His face in the dim of the test room looked older than his years. The run's success gave the foreman the documentation he needed to press procurement harder. It gave Harold the means to petition for a second press that would free the team from the makeshift die heating ritual. It gave the line workers a brief respite in the knowledge that, for the moment, their improvisations had been made safer and repeatable. Scaling produced its own set of tensions. Overtime accumulated in spreadsheets and muscle fatigue. The shop implemented rotating crews to preserve institutional knowledge and to spread the burden of night work. Young recruits who had never known anything but rationed weekends learned to schedule their lives around shifts. Some couples married between dawn shift and swing shift. Babies were born into neighborhoods where a father or mother only ever came home to sleep and eat before returning to the bench. The factory shaped lives in palpable ways. The war did not just alter the skyline, it altered how the town arranged itself. There were accidents. A pressure line ruptured on a press one day, scalding an operator's forearm. Safety procedures were tightened. A grating was added to a pedestal. Toolboxes were checked nightly. The injury was treated with care, and the injured man returned after weeks with an arm that bore a pale raised line where the burn had healed. He kept working, his motions a little different, more circumspect. The shop recorded the incident with sober language in the logbooks and adjusted practices. It was a reminder that improvisation had limits and that survival hinged not just on clever hacks but on disciplined safety. By now, the factory had settled into a rhythm that felt less like crisis and more like sustained, focused labor. The line churned. Fuselages joined wings in a steady ballet. Each completed airframe was rolled into the paint bay, where sunbursts of enamel glowed under heated lamps. Men and women stood back and watched an aircraft take color, a plain silver or a field-tough gray that would, in weeks, show soot and battle scars. Each plane was a monument to the 1,000 small decisions that had made it. When the first larger batch left the plant, the rail yard was packed. Workers gathered to watch the flat cars roll out under a pale sky. A handful of men who had welded the landing gear struts stood near the gate, cigarettes in hands that still trembled with the echo of sparks. A foreman placed his hand on the fuselage like a benediction. Someone tapped a small brass rivet and said, softly, "Go well." The train slipped into motion, and for a moment the whole town exhaled. Those planes flew missions that touched many lives. In letters later received and preserved, pilots described the Thunderbolt's toughness in prose that was half gratitude and half grit. One letter described how a pilot had made it back after an engine had been hit and bled oil until the gauges read empty. The heavy airframe, the well-placed armor, and a stubborn pilot's will combined to let the aircraft reach friendly territory. The pilot thanked those who built her in lines that blurred the distance between the cockpit and the shop floor. Such letters were pinned to the bulletin board and read again and again on slow afternoons. It is necessary, here, to be explicit and sober. Machines built in wartime enable violent ends. The P-47s that rolled out of this factory participated in operations that produced destruction and, inevitably, civilian casualties. The narrative of technical triumph cannot be separated from the moral reality that these aircraft existed to deliver force. The factory's workers, many of whom had family members in harm's way, knew this intimately. They held ambivalence, pride in craftsmanship, empathy for victims, and a wish that the skills honed under duress might someday be repurposed for peaceful ends. The script of their lives did not give neat absolution. It offered instead a complicated ledger of skill, intention, necessity, and consequence. War economies shift quickly toward post-war readjustment, and by late in the conflict, the question of what happens after the guns fell silent began to enter the shop's conversations. Men and women who had grown accustomed to the rhythm of production wondered whether their skills would be valuable in a peacetime market. Would the demand for robust stamped plates and heavy armor give way to consumer goods? Where would the presses go? These were not abstract concerns. They were futures to be negotiated. Some hoped for a return to things they had left behind, shops that existed in quieter orders. Others imagined converting their knowledge into peacetime industries. Aircraft adapted to civilian cargo work, parts used in tractors, or tools that would make domestic products more durable. The foreman kept a small notebook with margin notes on post-war transition, with items like train welders for consumer work and catalog jigs. It read like the minutes of a town hall. Workshops in other parts of the country did similar thinking. Some industrialists, seeing possibility, petitioned government for transition contracts. Academia sent representatives with pamphlets about retraining. The shop scheduled classes on blueprint reading and on finishing that might be as useful to a future auto plant as they'd been to the war effort. When the war finally wound down, the plant's initial reaction was confusion, followed by a slow, complex exhale. The demand for fighters diminished. Some orders were canceled. Assembly lines slowed. Faces around the benches changed as service people returned to civilian life and as older workers left for other jobs. A number of women who held critical positions were pushed out or encouraged to return to traditional roles, an ugly and complicated reversion that the factory's leadership tried to temper with promises of training and placement. Not all promises held. For some, the end of wartime urgency meant a painful lowering of status and pay. Machines that had labored under strain were idled. In the hangars where completed P-47s had once lined up in long rows, dust gathered. Some aircraft were stored, others were parceled out to allies, many were eventually scrapped or modified for peacetime uses. The tools that had once been scarce, hardened reamers, calibrated presses, found their way into different industries. A press that had stamped fuselage stiffeners might later stamp refrigerator panels. A lathe that had turned bushings would be used to machine lawnmower parts. The technical know-how did not vanish, it diffused. The people of the factory faced the tug of different narratives. Veterans returned and sought jobs. Some found positions in manufacturing that matched their experience. Others used the GI Bill and left for college, moving into professions that had little to do with rivets and dies. Communities changed. Memorials were erected in town squares and veterans' halls where names were read aloud. The bulletin board that had once carried deployment telegrams now held invitations to dances and notices of employment fairs. The physical space of the factory went through transformations too. Some buildings were repurposed into warehouses, others bought by entrepreneurs who saw opportunity in cheap floor space. A few acres became parks. A hangar became a distribution center. In one town, a former assembly bay was converted into a vocational school, where the next generation learned welding and machining, their instructors often veterans of the same lines. Museums eventually collected artifacts. A Thunderbolt, cleaned and restored, hung in a national museum, its skin buffed and its canopy clear. Visitors stood underneath it and read placards explaining production numbers and combat roles. A different exhibit displayed a worn die from the factory, heat-flushed and scored, with a label noting the improvised die heating technique during the shortage of tools. Exhibitions discussed both the ingenuity and the costs, offering a nuanced picture rather than a uniform celebration. The artifacts became anchors for complex conversations about technology, labor, and war. Years later, friends and former colleagues would meet at reunions, and their memories would take on the tones of legend tempered by humility. Tom, older now and with hands that had stopped being as steady, would tell younger relatives about the nights under the lamps when a whole lot of people simply refused to give up. Ruth would tell them about rivets and photos and the way a single letter could change a man's week. Harold would show the sketches that had saved hours of assembly and shrug at how simple the final solution looked on paper compared to how difficult it had been in practice. They did not romanticize everything. They remembered missing tools, burned fingers, and close calls, along with the small, defiant victories. The factory story became tangled with the town's memory. Children who were toddlers during the war grew up to walk past the old gates and point to a plaque. The narrative that the plaque offered was curated. It honored craftsmanship and resilience and recorded names. But the people who had lived it knew the story's raw edges, how scarcity shaped judgment, how improvisation sometimes endangered as much as it saved, how technology could protect and yet also be part of a machinery of destruction. They carried both pride and reservation like medals on their chests. In quiet moments, those who had been in the shop would sometimes return to the empty bays and listen. The echo of a press, the remembered hiss of a grinding wheel, the rhythm of rivet guns. These sounds lived like memory in the rafters. A former machinist might stand and lay a hand on a cold die and recall the heat of welding, the smell of flux, the steady hum of an engine under test. For many, the memories were ambivalent sweetness, the satisfaction of craft intertwined with the knowledge that what they had forged had also been used to harm. When museums restored a P-47 for display, volunteers sometimes included former workers. They would run a hand over a rib and nod at a join, approving or suggesting a minute correction to a restoration technique. Their participation felt like a gentle closure, not an absolution, but a respectful continuation of the labor they had once done under different circumstances. In the end, the lesson the shop taught was less about triumph than persistence. The factory had been a place where people were forced to invent under constraint, to test and fail and keep testing again. The improvisations, lathe beds shimmed with what was at hand, a die heated with torches and asbestos pads, a sleeve replaced with oil can steel, were not acts of romantic genius, so much as practical responses to a stubborn problem. Planes had to fly, and people's lives were tied to whether those planes held together. There is a particular image worth keeping, a single fuselage in the painting bay, silver flaked with primer, where a worker has left a thumbprint in the drying enamel. It is both a careless mark and a human signature. In the shop, hands left their marks in more permanent ways. A file that saved a bearing, a bracket redrawn to be both simpler and stronger, a heat treatment schedule that balanced ductility and strength. Those marks were not celebrated with medals so much as recorded in binders and passed along orally to new hands. And yet, the memory of scarcity remained instructive. It taught that tools, like trust and supplies, are features of any production system that cannot be taken for granted. It taught humility in engineering. Materials speak if you listen. And sometimes the most elegant fix is the one that humans can repeat, not the one that looks ingenious on a drawing board. It also taught moral caution, that technological skill is a powerful force, and that the ethical dimensions of its use require as much attention as the technical. Long after the presses stopped, long after the men and women who had made do had grown old and some had passed away, the sound that haunted memory was not the roar of the engine in combat, but a quieter, more intimate note, the tick of cooling metal. In an empty hangar at dusk, where a restored P-47 might stand on display, the cooling of its skin produced a small metallic song, tiny clicks and sighs as the metal settled into a new thermal state. It was not a triumphant anthem. It was a sound of completion and of consequence, a sound that carried both the warmth of making and the chill of what that making had enabled. When the factory's lights finally dimmed for good, the place did not disappear. It morphed. Its bones held other uses. But the stories, the ones told in quiet voice at reunions and the ones pinned to museum plaques, persisted. They are stories about hands finding ways when tools ran low, about the ethics of creating instruments of war, about people who did not simply obey orders, but who thought, measured, and judged under pressure. They are stories about the P-47s that left the plant and the people who made them. Stories that ask us to hold two truths at once: admiration for human ingenuity and an awareness of the costs such ingenuity can carry. If you ever stand beneath a restored Thunderbolt in a museum, look beyond its polished skin. Imagine for a moment a scene in the early hours of a winter morning. A die heated until its size blew at the edges. A woman steady at a rivet gun. A young mechanic who has learned to listen to bearings like people listen to music. Picture a tool rack with more hooks than tools. And then picture hands that, nevertheless, find a way. There is in that image a stubborn, fraught beauty. The beauty of people refusing to let scarcity define them entirely. The P-47s that flew because of that refusal became part of a larger history, one that included courage and doubt, supply chains and sentinels, letters from mothers and engineers' sketches. The factory's contribution was neither the sole cause of events in the sky nor a minor footnote. It was a node in a complex web of causes and effects, a place where metal was made to mean something more than itself. And in the quiet that followed, in the cooling metal's final tiny ticks, there remained a simple human truth: that the craft of making endures beyond the machines, inhabiting the people who once bent, forged, pressed, and tested. Their hands left an imprint not only on rivets and skins, but on memory. That imprint asks us to remember both resourcefulness and responsibility, and to hold in our minds the full shape of what it takes to build and what it means to build for war. If this story moved you, if you want more deep dives into the workshops and workbenches that fashioned history, subscribe and join the conversation. Tell us which factory story surprised you most and why the noise of metal still matters to you.